welcome everyone. I want to say how impressed I am that so many people are here for one of the last sessions of the day. You know, I always find that those end of conference sessions are sparsely attended by very interested folks. So either you guys have nowhere else to go, or I've got myself a nice audience of people interested in big data and Hadoop. Which Hadoop, yeah? How many of you guys are actually using Hadoop right now? Just so, it's definitely the latter. This is great. All right, so before we get too far into things, probably should answer the fundamental question, who am I? I'm a regional director of services at Hortonworks. And our little catchphrase is, we do Hadoop. Probably a better thing is we're the ones who are writing Hadoop with over 160 committers and a lot of other folks who add code anyways and without having the committer status. A little bit about myself. I've been doing development in a variety of platforms for a lot of years, and I've created an awful lot of bugs. I'm certain you guys have never seen bugs before that you've created. They're always something someone else does. For me, I'm willing to fess up. I've created a lot of bugs. There's a little problem with bugs, though. I don't like them. I don't like them at all, because what always happens is I get called about a production problem that has to be solved right now at the worst possible moments. And so over the years, I've really gotten into testing techniques as a way to make my life better. For me, testing has nothing to do with my employer, my project, or any of those other noble concerns. Folks, it's all about me. It's all about making our lives easier. So when I came into the Hadoop space, I looked at it and I said, uh-oh. Here is an environment that I'm not going to be able to use all that unit testing concepts that I've found over the years. I'm going to be in trouble. Fortunately, that proved to be quite wrong. So, who are you for this discussion? We found out a lot of you are using Hadoop. Are any of you guys using Hadoop in production? All right, excellent. How many of you are using the Hortonworks distribution? Okay, we got to talk to the rest of you guys. So, a little plug for Hortonworks. Our distribution is completely open source. It is truly the Apache Hadoop. There's nothing proprietary. There's nothing you got to spend extra for. You pay for the support, having someone at the other end of the line to answer your questions. You pay for training to teach you about Uzi and Pig and all that other stuff. You pay for folks from my team to, help bootstrap you into Hadoop, to help you do architectural reviews. That's it. The software is free, open source. I think that'll be the end of my plugs for Hortonworks, but consider it. I'm a big open source fan. That is, gentleman in front said, you need to come work for a company because you really believe in it. And I really believe in open source. I don't like, it's free, but sort of models. It's either open source, fully community driven, or it's not. Even though we have the majority of the committers, Hortonworks cannot just check in code without getting approval from the general community. That's a really cool aspect of open source. So I lied, actually, there was one other plug. I'm looking to see if through this discussion and others, if any of you are interested in coming to work for us. We're growing really fast. If you are, see me at the end. I say that in case you decide to leave somewhere along the presentation. All right, so enough of that sort of corporate introductory stuff. I love Hadoop. I love distributed compute. I've been doing one form or another of distributed compute since I was a teenager. and that was a couple years ago. Good Hadoop development is hard. All of those folks who raised your hands, who are in development role, you know what I'm talking about. There's a lot of data. Maybe that's why they call it big data. A lot of data doesn't sound so good. And with lots of data, we've got a lot of problems. We've got a lot of complexity that just doesn't exist in the normal world. And you may say, hey, you know, that's what Hadoop and big data tools are supposed to solve. It's supposed to make it so easy to work with lots of data. Well, it's easier than dealing with a Postgres instance or an Oracle rack, but there's still a lot of things we've got to pay attention to. It's different. We've got volume. Where before, back in the J2EE days, I used to think of a big file as, I've got a file that's a meg. My laptop can do a meg. My iPad can do a meg. I'm dealing with customers who have, multiple petabytes, or they have very complex unions of terabyte-sized files. And that volume is kind of tough. The velocity that it comes at. The prior speaker was talking about Internet of Things. I've been playing around with the Internet of Things. I used a Raspberry Pi to find a leak in my house. What I did was I hooked up a microphone to the Raspberry Pi and set up a data feed using big data concepts so that it would generate an email every time the ambient noise went up. Velocity creates all sorts of problems, even when you're talking about one Raspberry Pi picking up audio signals in a house. Imagine what happens in an enterprise where you may have several thousand, tens of thousands of sensors. It gets really fun fast. Variety. It used to be you threw all of your data into your Oracle, your SQL Server, your Postgres database. You knew how the data was organized. I'm dealing with projects that have XML, CSV, TSV, some sort of crazy text file, binary, XML, all as part of one batch file, batch program, and joining them all together. That variety gets kind of interesting. And then if those problems, making Hadoop development hard, was not enough, we have this expectation that you should be able to turn around your analysis, get your new big data batch jobs running really quickly. For those of you who raised your hand saying you're Hadoop, do you agree with what I'm saying here? You're under a lot of pressure there for quick release cycles? I don't know about you, but when I'm under a lot of pressure to get something out right now, I make mistakes. I make bugs, lots of them. This is not good. That means I'm likely to get interrupted at midnight when the production operator tells me that there's some sort of null pointer exception, or when the marketing director is looking at the report and saying none of this stuff makes sense. I don't like that. But you may say, I'm a good coder. I'll find it. And if there's only a 1% error, who cares? On a billion-row data set, what's 1%? It's a lot. I had somebody in the financial industry tell me that they didn't need to worry about, 1% error. Well, let me tell you, 1% of the money on Wall Street, I'll take it. It's a lot of money. Big data amplifies small problems. And you have to keep that in mind all the time. So what are these problems? Well, the first one is the speed of light. According to Einstein, though some physics friends of mine telling me that maybe this isn't true. The speed of light is a constant and you cannot exceed it. Why do I raise the issue of the speed of light? It's simple, because those electrons are moving near those sorts of speeds through the copper circuits in our computers. That's my barrier. If you go run the Hadoop I/O tests, you'll find out what sort of data throughput you can support. Quite often I'm seeing 20, 30, sometimes 50,000 meg per second. That's a lot of data. Until you start thinking, well, let's see, I've got one 2 terabyte file, I've got another 10 terabyte file, I've got this crazy XML file, and I'm all linking them all together. All of a sudden, 20 megabytes per second doesn't seem so fast. We have to find a way to, since we cannot speed up those electrons any faster, we cannot cause those disks to move any faster, we have to figure out a way to fool the system to achieve our performance aims. Data permutations. If you're looking at a small data set, you probably have a very finite number of data elements. If I've got 10 million rows, a billion rows, who knows what's in there? And if it's over a long period of time, I may have very clean data from the last 30 days, but maybe that definition of a customer status from 3 years ago in that same data set, that might not be so good. Or, more accurately put, it might actually be a different definition. That's a different variation of permutations of information that we normally consider. This makes our testing life a lot harder, especially if we're doing discovery analytics. And then we've got that whole issue of lots of computers. Hey, I dealt with big clusters back in the WebLogic days. I'd have 10 web servers there. They were basically working alone. Now I've got those 10, 20, maybe 100 servers. Maybe in the case of Yahoo, and which Hortonworks uses, 40,000 servers. That, by the way, is Hortonworks testbed. Now, and the data's moving all around, it gets interesting. You start to really care about value cloning when you're moving data between machines. So, let me pause for a second. For those of you who are currently using Hadoop in production, how are you guys going and figuring out how to test your programs so that you're not awoken at midnight? Or, yep.
So what we've been doing as an experiment is actually taking like a table sample and running the same job over like a sampling of the data rather than the entire data set.
Yes, that is the first thing you should always do. And I'm so pleased to hear that one, because everyone, you want to follow that model. That's where you start off with a sample. And we're going to talk about that during the sessions and strategies. Anybody else? So I'll assume that for the rest of you, the reason why you're here is because you want to find out how to deal with them. Either that or you're perfect. Now, we've got another problem, and that is time. So the consequence of not having a clear test strategy is it gets a little harder to fix things. We know about the traditional unit testing, time to fix bugs, as far, as it gets away from the developer. But there's something else, and that's true here too, but there's something else I want you to consider. What I want you to consider is what happens to your analysis after it leaves the batch output. So I want you to think about the mortgage crisis that we went through in 2008. All of the calculations to figure out the model and the security risks were done in the 10 years leading up to that. Look at how much time and effort it took to unravel those bugs. Now think about the analyses, the risk analyses, other types of analyses you're doing. If you make a mistake, the repercussions can continue to haunt you for quite a few years afterwards. And the effort to unravel that can be substantial. What we need is we need a set of tools and approaches that will enable us to verify when we are done. And done defined as achieving the customer's or your boss's, whoever is requesting the task, completing their requirements, not what you think the requirements are. So that's an interesting concept. What are the 4 things that we need to consider? Well, the first, which hopefully gets done as a matter of course, we need to make certain that it runs, that it compiles, and that in a variety of different data situations, it'll be okay. That's pretty simple. That's the line that I've heard from, I've probably used it once or twice, so I'm not certain. Oh yeah, the cameras are on. I shouldn't be saying this. But the whole bit, it works fine on my machine. Well, it doesn't really work until it works on the production machine. The next, and this is probably the most important of the 4 items I'm going to mention, it has to be functionally correct. If your boss says the requirements are A, B, and C, you need to be able to prove that when certain combinations of data happens, the A requirement is met. When other combinations of data, the B requirement is met. That way you can go back to your end users and say, I know this will work. I know it will work because here are the tests that tie back to your requirements. If you can do that, and your data filters are correctly meeting the requirements, your loops, your branches are meeting the requirements, you're done. Your calculations are 1 + 1 is equal to 2. You're done from a functional perspective. You need to make certain you can start to deal with interfacing with the whole environment, that you're correctly referencing your resources. If you're doing some sort of side data set that you actually loaded from the correct directory within your cluster. And mind you, everything I'm talking about is applicable not only to Hadoop so far, but any large data situation, whether using SQL Server or MySQL or anything else. The next problem, which is also true in those other data environments, is you have to be able to deal with things that go bump in the night, your exceptions and your errors. And there's a couple of aspects that we need to consider. So first and foremost, when there is an error, we have to make certain that the system is left in a safe state. One of the joys of Hadoop, I always hear this as a problem with Hadoop, one of the joys of Hadoop is data is immutable. So if I'm working off of a raw data storage approach, all I have to do is run the lineage of jobs, and I should be able to recreate everything. Now, there are gotchas there. We need to make absolutely certain, though, that you've left the data in a clean state. We also need to make certain that we correctly gather the information to help diagnose the problem. I love Hadoop, and my favorite programming language in the Hadoop world is Pig. As much as I love it, I gotta tell you, some of the exceptions really scratch my head. It's just, I don't understand. You agree? Oh, no, there's some other ones too. So, we want to make certain we're pulling out the right information so that you can look at that problem. You can say, yes, I understand what's wrong here. And then we need to go and notify someone that the tree fell in the woods when no one was around, since a lot of the stuff runs at night. So we need to make certain that we have proper notification of these problems. And then we need to, coming back to my original comment, where we leave the system in a safe state, we need to make certain that we can rerun everything and it's not going to blow up. So I mentioned data mutability a moment ago. A lot of programs, the tools like Pig, if you try to write to a temporary output file or a final result set, it says can't do it. We have an exception there because it doesn't want to go and destroy data. So you want to have a way to test to make certain you've caught all of these things and you don't go through a 2-hour run window only to find that the final output was killed because there was already a leftover result file there. These are the 4 things that I've identified that are kind of useful to verify in your testing process. Like really useful. But if you think about it, that covers a lot of ground. We have to look at our loops. We have to look at our conditions. We have to look at all of the output points. That can be a lot of testing. We're trying to be able to address faster release cycles. We're not trying to slow the process down. So to this end, a rule that I find very important is the Materiality Rule. And what the Materiality Rule says is that I'm going to go and look at the conditions, the requirements, which are of great importance to the business, and then I'm going to go and look and cherry pick. I'm going to figure out which ones are easiest for me. Because as I mentioned at the beginning, this testing is about making our lives easier. So we want to go and get as many tests created so that we can have comfort in the system. I've listened over to the years to the testing community say, we need to aim for 100% test coverage. Hey, that's great if you can pull it off. I like to sleep. And if I covered 100% of the test cases, that sleep would get imperiled. So pay close attention to the Materiality Rule. By the way, that Materiality Rule works for most things. A variation of it you may hear is the 80-20. I like referring to as the Materiality Rule because it's the tests that are material and feasible. The next thing we need to consider is we need to make certain the tests are light and fast. I'm playing around with a Pig example for a customer right now. And I was a little sloppy when I started on this yesterday. I was running it through the sandbox, which I'll talk about in a moment. And the run times were probably 30 to 50 seconds on reasonably small data sets. I don't want to spend that time. That's getting into my time. I want something that's lightweight and will go by, will execute quickly. I also want to make certain that I cover the right range of tests. I want to have a nice blend of positive and negative tests. Positive tests are where things are working nicely, and negative is where I'm planning for things going bump in the night. All right, let's come back to testing. Here's our world. This is all our data, this big green blob. 10 terabytes of good hunkin' data. Now, if I've got 10 terabytes, and if you generally figure, a rule of thumb I follow, it's not always the case, it takes about an hour to move a terabyte. Well, that means I got 10 hours. Oh, that sounds like fun. So what do I want to do? Well, what I want to do is what the gentleman back there mentioned as his approach. I want to create a sample. And I want that sample to be as small as I can get away with and still prove out the requirements that I need to deliver on. Now that 10 terabytes maybe becomes a megabyte. I can deal with that sort of time frame for moving, and I don't even have to write any unit tests or anything else. By shrinking the data, I've made my life better right away. And so the first thing you should consider for testing is your sample size. So, We have a lot of data scientists. They always talk about problems with samples. And we should take a moment and think about what sort of sampling problems can we run into. Well, the two that come immediately to mind is a sampling error, which purely by chance, I don't have the data in there that I'm going to need for my condition. This is a pretty gnarly sort of item. If you go and you take that 10 million row data set and you drop it to 1,000, are you really going to have in those 1,000 rows all of the data values you need to test all of the conditions? I don't know. I've definitely seen situations where the tests have run, everything's green, and then it blows up. Why? Because the sample never tested. In traditional Java, we think of it in terms of code coverage. There isn't really a code coverage test tool. You can kind of do it in the MapReduce. So we have to really think about this, and we have to make certain we protect ourselves. And there's a couple of approaches. So within Pig, there's a tool that, a command where I can sample the data set. And so here I've got a very simple 5-line program that'll take 1% of all of the data. And, it's pretty good. It's probabilistic. Now, one of the things I can do, though, because there's always the risk that I may miss one of the data values that I need for my test, what I can do is right before this sample, I can set up a filter on that load operation. So I can say, give me all of the rows where the field 1 is equal to the value of A. That's a value in my code. That's something I want to test. Now we start to get into a way where I get past that randomness that my data scientist, statistician friends like to see, but it becomes useful for me because I can now make certain that I'm going to have the test data that I need. I can also do this in MapReduce. Instead of 5 lines, it's a lot more lines. Now there's another approach to consider that I like even better, and that's manual sampling. Or you can call it's where I make up data. It doesn't have to be more than a couple of rows. Sometimes I don't even need more than 1 row of data. And I can also, if I set it up right, embed it in my test script. That means I have a fully repeatable test. I don't have to worry about my data set changing. Oh, baby, now we're going someplace. And now here we get to the tools, the things that make all this possible. So I'm going to cover 3 tools that are going to allow us to work with these data samples. MRUnit, PigUnit, and btest. Let's start off with MRUnit. We'll start off there because most people start off with MapReduce. MRUnit, in my opinion, is probably the most mature of the tools that I'm going to look at, and I'll just give you a little warning. All of the testing tools I've found so far, feel free to contact me and let me know if you disagree, are questionable maturity. That doesn't mean you stop using them. The world is improving. You need some sort of testing tool. But just know that sometimes there are issues. And I'll mention the issues as I'm aware of them as we go through the remainder of this presentation. So let's start off with MRUnit. So I'm going to flip over to real code. Since we're all real programmers, we can get away from PowerPoint. So I've taken for my examples the standard examples, and I've done it just to make it easier for you to go and repeat these sorts of tests at home. They're really kind of silly, though I think I've been able to point out a couple of issues here. So here's our word count. Now, I've made a change to the traditional word count. I've added a stop word list, and I've made it so it fits on the screen. You know, words like a, the. If I'm going to go count these words, I don't care about these sorts of things. And then, you know, I'm making certain it's checking lowercase, and then I'm only including them in the output from the mapper if it's not in the stop list. And so, you know, it looks good to me. Let's go down. And then the reducer for our word count is, you know, it's a stock thing. I just add the value that I pass to the mapper. Nothing fancy. Can't run into any problems here. You know, I haven't done anything that complex, right? Okay. So, and then we've got our main class. Let's go look at the test in MRUnit. So, what I did was I specified in my setup, I specified the word count tokenizer mapper, the reducer, and then I just passed it into the MRUnit framework. Simple. Very simple. And then in terms of the code, anybody who's done JUnit, this should look pretty kind of familiar, at least with the @test. So here's my input string. So remember I was talking about sample sizes? Well, I've taken that sample size to an extreme. 1 row of data. Isn't that sweet? Now, to go and test this in a full cluster would probably take me around a minute. So what I'm expecting for an output, I'm specifying the with input being this text string, which will go through that mapper we looked at a moment ago. It'll tokenize it, and then it'll return a count of 1 for each of the non-stop words. And, you know, we're not expecting to see this or can or be because those were in our stop word list. Real simple. And then for the reducer, I don't want to have a dependency on what went on in the mapper. I want to test the reducer separately. So I give it a bunch of values, you know, the 1 key map. It's real simple. Okay. How many of you guys think this test is going to pass? How many of you were looking carefully at the source code? So we got 1 skeptical. Okay, so let's run it. Let's see what happens. I think about a minute running in a Hadoop cluster. Oops. Well, you knew with that introduction that it was going to fail. So, what's that? What's that? No asserts? Oh, well, yeah, there's an assert. Just it failed on the assert. So one of the things I did was I had it list out, did very sloppy programming. I did a system out of the words that were passed, and look at this. This that can be this. It sounds like a philosopher talking or something like that. Those are my stop words. So let's go back and look at that code again that we looked at, all of us. And we said, looked fine. Oh yeah, I kind of missed a knot. I make this point because it's the stupid things that really kill us. Everybody in this room, I'm certain, knows that, and if you're looking at it and you'd find it, but hey, we get tired, we miss things. Now, before I rerun it and prove that it does work, I want to come back to my maturity comment. So for those of you who are familiar with JUnit, they're nice outputs. Java lang assertion error, 6 errors. Missing expected output map, 1 at position 0, got this, 1. Missing expected output feature, 1 at position 1. Be real. But, as I said, this stuff may be immature, But imagine if you had to spend a minute every time you ran some sort of program. Imagine if you didn't have all of the tools that MRUnit provides to simulate a cluster. We can suffer with these bad error messages for another couple of versions. All right, so let's take this. Let's go rerun our test. The knot is in place. When the test is green, the code is clean, baby. So there we go for both of our reduce and our mapper tests. Now in a real world situation, you wouldn't have just 2 tests, you'd have a lot of tests. But now if you think about each of these programs not taking a minute, but taking practically nothing, 1 second for both of those, we can do a lot of testing now. So in terms of some of the problems that I mentioned regarding testing, they're not as significant anymore because that big data has now been shrunk to little data. Yep.
So in this particular case, I think it's better to unit test the mapper business logic instead of building MRUnit.
Well, that's what we're doing. We are unit testing the mapper and the business and the reducer separately. Well, sure. Yeah, and I've asked that question as well. The answer for the MRUnit and its advantages is it brings all of those other library and all of those other utility functions along with it, and it sets up a runner to test the map. So it makes it a little easier. Do people use JUnit and just test the mapper? Yes, but they have to do a lot of setup work first. MRUnit doesn't take, it becomes easier. It's a convenience factor, but yes, you can use JUnit. It's up to you. But and if you go the JUnit and are willing to go through all that dependency, you get cleaner output, that's for sure. But I went down that road, and I'm pretty happy with MRUnit now. I find I can evaluate more things, and I don't have to worry about any sort of methods that are linking to other aspects of the MapReduce framework. Now, if you've written your code to not rely on a lot of the Hadoop framework, then JUnit becomes pretty easy. If you just have one call out that's just your logic and you're passing the values into there. But if you're getting into some of the other components, I just find it makes it easier. All right?
Then the test will be just for whatever the MR framework, whatever the business logic linked to.
Yeah, and that's an important point whenever looking at a test framework. The bias that the runner will have. One of the beauties of MRUnit, more so than the other two that I'm going to talk about, is that it is heavily used by the Hadoop community, the committers. So it's used for quite a few of the release tests. So it's going to be more representative, MRUnit, not so for the other two I'm going to talk about. Though I'd kind of like to see that change. But the comment also gets back to my maturity. You do want to be comfortable with the tool before you accept it. You need to know where the problems are. I find that these three tools make life easier. They are not what I would call JUnit quality of test tool yet. But I find they work. And the next one I'm going to show you is you're really going to have some questions about. All right. So We can get past all that silly stuff. All right, so let's go into the next type of testing, and that's with Pig. So built into the Pig language, there's 4 commands: dump, illustrate, describe, and explain. And these, when I was learning Pig, I was told these are the tools that you're going to use to test your program. Well, let's put it into pretty standard language and get away from the the jargon. Dump, all that is system out println. It's nothing more than that. Illustrate's kind of cool. It's sort of like doing a select star from a table. It's cool because you can see the data values that go with the fields. I like that. Describe is critical as a command for figuring out what's going on, because that will tell you what are the data types that you're currently looking at. It's not uncommon in the Pig world to start off thinking that you're dealing with a normal field and find out you're trying to pull something that's deeply embedded within a tuple or bag or any of those other crazy things. So describe helps you figure out where you are with stuff. And then there's explain. And explain is necessary to figure out some of the performance aspects, but it's really cryptic to read. None of these tools, though, address the functional. None of these address anything we've been talking about in this session yet. That's a problem. We need something else. So if I have this simple counting script that goes and builds a group and then generates a count for each of the members of the group. This is, by the way, the standard PigUnit test script. I want to be able to test this. I want to make certain it's functionally correct. And I can't do that with dump or explain or any of those other things. Well, I can. It just figure a minute a run. I don't want to spend that time. So there's a tool, back up, called PigUnit. And PigUnit allows me to go and run this script with sample data, just like we did with MRUnit. I can have 1 or more rows, and I can evaluate things. It's fast, it's cool. There's some problems coming back to the maturity theme that I've been hitting on. So the first of these is, unless you deal with some of the mocking solutions that are out there, and I was tempted to get into them for this session, but I decided to spare you. So with PigUnit, if your script uses more than 1 input file, you're kind of moving into some turf where you'd be all alone. As I said, there are a couple of projects out there that use mocks to inject multiple files. I consider them even less mature. Another concern is PigUnit will go and override the store, load, and dump. And I'm convinced, though I don't see the direct evidence, that sometimes it takes out the describe statement as well. Maybe that's just my vision late at night. So those become significant so that if I'm doing testing and I'm doing a store and then have another job in my test sequence that picks up that value, I'm not going to get it because I'm not going to be able to write it out. Now we can argue that it's appropriate to override the store because this is a unit test. And so we don't really want to think about the integration issues of a write. That said, these limitations, PigUnit, I probably use the most of all of them, even though it's got issues. I like it because it helps me develop quickly in Pig, ironically. So here, let's. All right, so here we have our script, and we're loading a file called input2, and we're storing the query's limit into a file called output. You can use anything you want. And it's standard Pig logic here. Let's look at the PigUnit code itself. So this will run outside of the cluster. Same thing as with MRUnit that we talked about. So we get some performance. Oh, one of the things I forgot to mention is that output is going to be defined by a parameter. Oops. N. One of the things you should do for your code is allow the use of parameters, because that can encourage reusability of code and processes. So if I go to the PigUnit Hello World, and this is just a standard PigUnit test you see out on the website there, we've got our arguments. We've got the instantiation of the pig test, passing in the arguments. We've got our input. Now you'll notice that I was loading, I think I still had it input 2, and here we've got a variable input 3. Our output is, we're specifying it as normal record, Yahoo, 3, Facebook 2, and then the assert, the run on this is right here. And where we do assert output, and we're saying we want to inject the variable from this Java program, input 3, that's this list of values, into the pig script data variable called data. Likewise, the query's limit should match what we have as output. So let's go back, make certain that's clear. So, here's the data pig script. You do not assume that that next parameter there is the file name. It's just referring to this field name. The reason why PigUnit cannot support multiple files is because of the way in which the original author set up this assert output. You have your input, comma, and then your output sets. So running this can take some time if we're looking at it in a regular cluster, because we've got to start up all those JVMs. There's a lot of things we need to do. Now you'll notice that this is a little bit longer. It's done. It took us 4 seconds, so it's 4 times as long. It does not mean that Pig is 4 times slower than MapReduce. It's kind of handy because I can go and look through the variables that I'm using for configuration. I can look at the output, and I can use that to better understand what's going on with my test. What I see is that I don't see any exceptions. That means everything's good. Once again, getting back to my maturity comment. But there is some information that is useful here. I can see the total duration. If I was doing command line, I'd probably look here. In IntelliJ, it's nice enough to tell me. I can see some of the groups of operations, and one that can be particularly interesting is this job DAG space right here. Because what this is telling me is how are the jobs that Pig is creating organizing the information. This particular Pig output is just setting up a sequential flow. Job 1 runs, then job 2, then job 3, 4, and then we're done. If I'm concerned about parallelization, I think I have a problem with this test. We're not talking about the functional aspects of the testing, but we're getting some byproducts here. Functionally, we know this is valid. Now, to give you an idea what this looks like when there's a failure, let's go take the same test, rerun it, goes, does its thing, da-di-da-di-da, and we get an error. It says comparison failure. That's how we know it failed. And IntelliJ has a nice little feature that allows us to click on it. We see that we were expecting only 2 occurrences of Yahoo. We found 3. So it's not the greatest in the world. It's got some issues, but it's really useful. Another item outside of testing where I find this really useful is if I'm putting together a script, I don't want to have to wait for a while to go and run the processes. I'm working on this stock market evaluation, decided to switch it over to Pig. I've got a data set that's about 5 million rows deep for my sample. Not much by big data standards. But it takes a while every time I run this stuff. If I can go and try out a concept in 4 seconds, that enables me to move faster. And if I can move faster, if I can get feedback, then that's another way I can resolve bugs, or rather avoid bugs. So I would strongly encourage that you go and you play around with PigUnit if you're using Pig. How many of you do use Pig? Okay. How many of you are doing MapReduce? So for those of you in plain old MapReduce, take a look at Pig. You know, I'm a Java guy. I run one of the world's largest Java users group, and I prefer to write in Pig. The reason, quite simply, I don't like to spend a lot of time doing things unnecessarily. And Pig's pretty efficient. So take a look at it for those of you who've already explored MapReduce. All right, so the last of the tools that we're going to take a look at is btest. So btest is a tool to go and test Hive. Hive is an amazing tool in the Hadoop ecosystem because it's gone from being a pretty kludgy SQL tool to being pretty fast. And the stuff that I know that they're working on right now is even faster. But it's SQL. We all know the challenges of testing SQL. And SQL, just like Java, has its own little sets of bugs that can sneak in there that you look at the code forever and ever. You know what's right and wrong, but you still miss the typo. We need something that will unit test our Hive scripts as well. And of the tools that I've looked at, btest seems to be the strongest. So for btest, what we do is we create a directory. And for this directory, we've got 5 files. We've got the setup HQL that creates the table and does some initialization for the system. This way you know that every test will produce the same result. Select HQL, that's my query I'm testing. That's one feature I'm not too happy about with btest because I probably want to put in my HQL file and I don't want to have to rename it setup. That just seems prone to failure. You know, the file gets missed. Input TSV, that's going to have my couple of rows of test data. And it's going to define what I'm going to put in there. The expected TXT, that's the output. And then the variables, which in our little test here is just going to be the table name. So one of the differences between this testing tool and the others is this one is looking at a whole directory. The directory is the test. So if I do an ls on that directory, you can see the files I mentioned, and you can see they're all pretty small. In order to go and run the test, it's also very simple. I just run the test command. I reference the directory, artist count, and then I specify I want to use the local config. So what are we looking at? So for my select HQL that I mentioned, we can see right here the use of the variable, the dollar table that I talked about. We're going to limit it to just the first 2 rows. Pretty simple stuff. I could copy my command in my HQL queries into here to test. And if I have a successful run, you know, we see our common theme. It doesn't tell me test successful. I really wish it would. It just doesn't blow up on me. If it fails, like I changed the count on the expected, I get an exception. This test was developed by Spotify, who's a very heavy user of Hadoop. It's pretty well beaten on, tested, validated. Other than the items I've just complained about, it seems to be pretty solid as a testing tool. So, I guess I'm running a little faster than I thought. So these are the 3 tests that I see that are meaningful. all three of them have their issues and their alternatives. There are a couple of other Hive testing tools that I've seen out there. B-test happens to be the one I find strongest. I'm waiting for somebody to get to a point where they can't stand the one pig file and set up a new project with real support to replace PigUnit. And MRUnit, I think, is other than its error message, is pretty solid. So if you're starting out with testing, start out simple. You can go and make all sorts of progress just by setting up a test environment to run your normal programs using, as the gentleman back there is doing, a sample data set. Try and make that sample data set as small as you possibly can. It doesn't really cost anything in terms of time to do that. You don't have to create any test code. You don't have to use any fancy utilities. You just run the program, and if it produces the output you expect, you just do a file diff sort of thing, then you're in a good position. It doesn't take a whole lot of effort to go and set that up. Creating your sample, that could take some effort, but once you have it, it should be pretty good. As you move forward, consider the materiality rule. Don't go and create the tests that are hard to implement first, and especially don't create them if they're a low value. Focus on the ones that are easy for you and that have a very high value for your customers, your users. That way, you get coverage for the items that your users care about quickly without a whole lot of energy. And we talked about sampling. So now the tests, keep them light and fast. The examples we saw, the slowest one was 4 seconds. Think about running the tests on any one of the distribution sandboxes. I defy you to be able to get a result going in 4 seconds. And it's not that those tools are slow, the sandboxes, it's that these things are built for large quantities of data. And you're not running through, for this testing purpose, large quantities of data. You're saying lots of data is a problem, as we talked about. I want to test the code, and I'm going to do it with a little bit of data. And then once I know that it's functionally correct, that it'll run in the way I expect, then I'll put the large quantities of data in my staging or production environments. Until then, keep your tests light and fast. And then the last couple of items are just general testing good hygiene. Keep all of your Hadoop code, your tests, in a source code management. Just because this isn't a true Java enterprise application, as I've heard some people say, doesn't mean that you shouldn't keep your HQL, your pig scripts, your MapReduce code in a source code repository. You need to. Use an automated test environment to go and validate your tests on a regular basis, not just when you think about running it. That way, if John down the hall decides to make some changes and you weren't aware of any changes made and he just copied it into the production environment, you'll be aware of the bugs that caused. And then maintain and publicly publish the historical results. A lot of people say, well, why do I care? All I care about is today's. Well, it's amazing how problems get into the cycle. And if you can go back and look and say, well, this test was running and it was running at 3 seconds 2 weeks ago, and then a couple days ago it jumped up to 15 seconds, but it was still running okay, that might be an indicator that there's a problem. If you have that historical data, then when the ultimate event that causes you to say, what's going on here, happens, you can go and look through the log of test results and the log of execution, test executions, so that you can figure out what might have led to that problem. So in closing, we've gone through 4 basic concepts. Concept of the data sampling. which normally when I give this presentation, nobody talks about sampling, so I really enjoyed this presentation today. And then the 3 tools covering 3 of the most common areas of Hadoop, MRUnit, PigUnit, btest. I think these tools have some growth ahead of them. There are some cautions, as we talked about. You can use JUnit. There are all sorts of ways to use JUnit or TestNG. I just find that these tools make life a little easier, and I can deal with those bad errors. Yes?
So we are going on to a path where we are about to deprecate all of our MapReduce and move entirely onto Spark. And so just, I see an OO. Is that a bad thing or a good thing?
Well, a friend of mine is a committer on that project.
So are there like similar tools for Spark? I know that there's less code in general, so testing it should be easier. Like just writing plain unit tests should be a lot easier. But are there any tools that you know of?
None that I've played around with. Yeah. You've got a little bit more abstraction, as I understand it. And I really haven't gotten that deep into Spark myself yet. But I gotta believe, because I know the Scala, everybody I know who's really religious about Scala, they're also religious about testing. So I gotta believe there's some pretty good tools there. I just can't comment on them. Okay. Any other questions? All righty. It's a very quiet group. So you guys learned a lot from the session? Good. So once again, name's Mark Johnson. If you're interested in getting involved with Hadoop, give me a ring. I can be reached at any one of those email addresses. LinkedIn. The source code with the tests I have in this GitHub. If you just look for MF Johnson for the GitHub, and then Hadoop testing is where I've got the latest of the code. Feel free to go and pull it down. I will confess that I am continually updating and playing around with it. I try to make certain it's always good, but just know it does change, and you'll find some tests in there that I didn't cover during this session. All right. Well, thank you very much for your attention. Hope you guys have one remaining session for Devnexus, and hope to see you guys around. Thank you.